All right, so we're talking measures of central tendency here, okay? And we're going to talk about a few more things. We've already talked about mean, median, and mode. Today we're going to talk about range, outliers, and standard deviation, okay? The range is basically how far spread out your numbers are. So what I would do first, guys, with your sets of data, with your numbers, okay, is arrange them in order if they're not already in order. So these numbers, okay, I would start with the smallest and obviously work my way up. The smallest number I see is a 30. Okay, kind of cross them off as you go. Then I got a 42. All right, looks like I have three 45s. Three 45s. Okay, I got a 48. I got a 52 and I got a 100. So that's the first thing I would do with your numbers before you do anything else, because with some of the things they ask you to do, you need them to be in order. Okay, now the range, okay, like I said, the range is basically how spread out your numbers are. For the range, simply you're going to subtract the top number. You're going to subtract the bottom number, sorry, from the top number. Okay, so my range for this set of data would be 100 minus 32, which is equal to 68. Okay, so that's your range. Your range is the top number subtracted by the smallest number. Top number subtracted by the bottom number. Okay, how widespread your data is. Now, some pieces of data, some collections of data have what we call outliers. Okay, an outlier, for lack of a better way of saying it, guys, is like the one that doesn't belong. Okay, so for example, if I was to give you guys a test and I had 5 people get in the 90s, I had another 7 people get in the 80s, I had 3 or 4 people get in the high 70s, and then one person had a really bad day. Let's say one person got like a 24, which obviously, hopefully, we avoid. Okay. But that number would be considered an outlier because it really doesn't fit in with the rest of the data. Everybody else was like high 70s on up. They were kind of bunched in that high 70s to 90s range. Okay. So that 24, guys, what that 24 would actually do, it's going to pull the average of the class down. Okay. That's what an outlier does. An outlier is either going to pull the average down, or it could also go the other way. It could pull the average up, depending on what the data is. So if you look at this data, all right, if we were in class right now, I'd say, what number do you think is the outlier? Hopefully, somebody would raise their hand and they would say that the 100 is the outlier here. The 100 is the outlier for this set of data. If you look at the other pieces, they go from 30 all the way to 52. Okay. Those numbers would have a range of only 22, but that 100 stretches that range out and makes it bigger. Okay. So that's what an outlier does. Like I said, it's basically a number that kind of doesn't fit. If you see something that's, obviously smaller or obviously bigger than the other numbers in the set of data, you have yourself an outlier. And that's going to affect, really not necessarily the median or the mode, but it's definitely going to affect the average. It's definitely going to affect the mean. All right, now, here's the one that's going to require a little work: standard deviation. Okay, you see the formula here. Okay, there's our formula. Okay, I promise you guys that formula looks a lot more complicated than it actually is. Okay, the first thing that we're going to do, guys, because you're going to need to know it, is you're going to find the mean. Okay, so we're going to find the mean of this set of data, the average. So I'm going to add up the 30, 42, my 345s, okay, my 48, my 52, and my 100. Oh, not equals 100, plus 100. Okay, so I got a calculator here ready to go. Okay, so 30 plus 42 plus 45 plus 45 plus 45 plus 48 plus 52 plus 100 is equal to, looks like that works out to be 407. Okay, there are 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So I'm going to divide by 8, and my average is 50.875. I'm going to round that just to make life a little bit easy to 50.9. So my mean is 50.9. Now, when we go to do standard deviation, I'm gonna go through this step by step, guys. I'm gonna make it nice and easy on you. Okay. So what you're gonna do, okay, see this X1 here? See that X1 and that X2 and all the way to XN? Those are basically the pieces of data in your set. So what they're talking about is the 30, 42, 45, the 45, the 45, 48, 52, and the 100. So those are your pieces of data. What you're going to do is you're going to subtract the mean from each of those. Okay? Subtracting the mean from each of those numbers. This is going to take a little bit of work. I'm not going to give you a lot of them to do, but you're going to have to do a decent amount of work. Okay, so you subtract 50.9 from each of these things. Okay, so you're going to need a calculator, obviously. So 30 minus 50.9, that is negative 20.9. And what you're going to do after you subtract them, you're going to raise it to the second power. Okay, so really you're going to multiply it by itself. Okay, so you're going to raise that to the second power. That would be 436.81. Okay, 42 minus 50.9. That equals negative 8.9. You raise it to the second power. That's 79.21. Okay, 45 minus 50.9 equals, that's going to be negative 5.9 raised to the second power. Okay, that's 34.81. Now, obviously, I know for the next two, it's going to be the same thing. 34.81 again, 34.81 again. 48 minus 50.9 equals negative 2.9. Raise it to the second power. 8.41. This is a decent amount of work. I know you got to take your time. 52 minus 50.9 equals, okay, that's an easy, nice small one. 1.1 to the second power. That equals 1.21. And then the last one, okay, I got 100 minus 50.9. I got my outlier. Okay, that's 49.1 squared. Okay, that's 2,410.81. All right, we're almost home free. Okay, you're going to add those numbers up, add them all up. Okay, so I start at the bottom. I got 2,410.81. I'm going to add. Okay, I'm adding all these numbers up right here. That's what I'm going to be doing right now. Okay, so obviously you're going to need a calculator. 21 plus 8.41 plus 34.81 plus 34.81 plus 34.81, okay, plus 79.21 plus 436.81. Okay, my final number after I added all those up, guys, is 3,040.88. Okay, so you add them all up. 3,040.88. Now you see this big fraction bar here, and then the n, you're going to divide by the n stands for number of pieces of data. Okay, so in our set of data here, we got 1, 2, 3, 4, 5, 6, 7. We got 8 pieces of data. So I'm going to divide this crazy number by 8. 380.11. Okay, and then the last thing you got to do is take the square root of that number. Take the square root of it, obviously on your calculators. Okay, you're going to have to use a calculator to do that. Okay, so I'm going to pull my calculator back up here. All right, so I got to do the square root of 380.11, which is 19.496. 19.496. Okay, and that number is your standard deviation. Okay, so that's a lot of work, guys. I know that's a lot of work. I didn't kill you with problems. Okay, to recap, okay, the first thing that I did to find the standard deviation was I found the mean right here. Okay, I found the mean. I got 50.9. Okay, I took each of my pieces of data. Okay, I took each piece of data and I subtracted 50.9. Okay, this is just a lot of bookkeeping, a lot of bookwork. When I subtracted, okay, I subtracted them and I squared them. That's how I got these numbers here. Subtract, squared, subtract, squared. Okay, subtract, squared, subtract, squared, subtract, squared. Okay, in the red box, I added all those numbers up. Okay, so I added all those numbers up. That's where I got this number down here. You divide by however many pieces of data there are. In our data here, there's 8. So you divide by 8. And then the very last thing that you do is you take the square root. Okay, so we got 19.46. Guys, this number is going to be a sloppy decimal because you got a lot of action here. Okay, hopefully you're able to follow that. If you're having trouble, just come back to this video and look at it again and kind of have it on as you're doing the problems. Okay, all right, good luck.